Good morning, boys and girls, and welcome to the Stinkbug Works. You know, that secret place. Anyway, I've had a lot of questions about my new challenge and the single-stepped hydro. This, of course, was Jay Turner's pool racer. This drawing here built this, which is prototype number 1 of the JetStepper. So let's talk about prototype number 1 for a minute. I put this nice long fin on it so you'd have a way to get the handle off. I also did what Jay did. I put a plastic transom on here to screw your hardware into. I used a conventional kind of motor mount and servo mount. Mainly, I use these so I can get the servos in and out. Normally, I just glue them in, if I'm trying to build super light. But I wanted to be able to get these out, so there it is. And my batteries were all set up at the time with larger connectors, XT60s. And so, I'm playing around with battery size and such and getting your weight and all. And then Jay had his turn fin mounted in the center, and so this doubler here, I added appropriate area to give the screws here some meat to bite into and give it some structure in that area. In this one, I used a 16th drive, but an 1/8" drive is easier to source and such. You could put a strut and a flex drive on it, but that's so much weight, cost, and complexity. And remember, I'm giving bonus points for being cheap. One guy might be faster, but if another guy does it at half the price, gotta give him points for that. So anyway, this was prototype number 1, and it had successes and failures. Prototype number 2, actually, Wayne has. I built prototypes number 2 and 3 simultaneously. Prototype, the one I kept, has non-trips on it. Wayne's is just square-edged, and I wanted to build 2 to compare the handling and such. And quite frankly, I can't tell a difference between the square edge and the non-trip. And we're going to talk about that when I get to the Goldfinger. Anyway, so I used a spoon here because I was changing motors around and I needed some room, and you see I've been grinding out under there, and I've tried all kinds of combinations in here. This one was the one that was the rocket and the underwater fish, and you saw how poorly it ran with those 14 series motors, so they're just out of the question unless you get a real high KV one and put it on a gear drive. But again, where are you going to get a big enough gear drive for that motor? So if I want gear drive, I probably think park flyers. And you see the problem. We go around and around and around with this. Again, I used a bolt-in servo because that was my thinking. I wanted to get it in and out. This hull is still usable for powertrain experiments, so I'm going to keep that on hand. I could probably get away with prototype number 1, although I think the drive shaft has been donated to another project. Prototype number 1, 2, 3. Prototype number 4, I used an asymmetric design. I put a non-trip on the outside of the turn and just a square edge on the inside of the turn. I mean, I'm not going to be turning that way. I don't need a non-trip on that side. So that was one thing, and you see I did kind of the same thing with the prop shaft support just to be cute. One of the issues is the angle of the drive shaft. Ideally, you want it between 0 and 4 degrees, but these are winding up around 7 degrees. And I've gone as far as to, push the propeller behind the transom so I could actually not hit the bottom of the boat kind of thing. But depending on the power system, I've been looking at these little gear drives, which means I can get the point at which the shaft exits the hull lower and lower and lower. You know, go back to this drawing here, you see where the shaft exits the hull. If I could get that point lower and lower and lower, that would flatten this angle out. So that's something to think about in your power choices, is where this is going to exit. Now, remember, the first one, which was copying Jay's design, had this exiting in the aft part of the hull, whereas in my first prototype, I'm dropping it down into the step, and then later prototypes, well, this one, the last one, I'm getting it further and further into the step to try to flatten this angle out. So more to think about. If you can get something that has a small diameter at this point right here, then the better. So a lot of thinking you got to do. That's about it. This, I found out, probably the best way to get your servo to work. Just glue a servo here. I hogged out some foam and do the 1/32 wire and capillary tube that Big B and I like so much. And I wanted this off to the side to be out of the way and such, so I didn't have to cut too much out of the hatch to get it to fit. And I find this to be a good way to take up, as the rudder swings, the distance from the center line of this to the center line of that changes. So I just put a little loop in it and came in the other way, and that gives it, you know, as it turns, you see how this moves a little bit and this wants to bend. It just makes this rod effectively that much longer and that much easier to bend. So that's the way I like to deal with that. So I think I've given you a lot of good ideas right now. Again, these are the plans, but that's for this guy. I've modified it up to here. And in fact, you see where I increased this doubler here. That was actually this thinking. I don't need that, so that can just get cut off. And in fact, well, I'd still want that doubler there, yeah. But I just cut that little tang off, so I just have a single doubler. And this, by the way, is a step for the front end of the hatch. I said this earlier, if you want to have a higher profile, you could put another block of foam there, or wood, and a block here and a block here, and raise the hatch up, you know, 1/8 of an inch, 3/16 or 1/4 or something like that, if you wanted to generate more room in here. Just some thinking. I'm sharing some thoughts because, quite frankly, I want you guys to get an answer. I don't want to make it hard. I want to make it easy. The problem is, for one person to do all the testing of all the systems available, I can't do it. So I hope each of you will kind of go down a different path, and then we'll have some real good comparisons to make as to what would be the ideal choice for this. So that's my plan. That's my thinking. Until next time, Jet out. Hey, boys and girls, Jet here with just a little postscript on the prior video. A couple of other thoughts I thought I'd share with you. On the hatch, you got to do a little carving here to clear the components. And what I did is I carved out a hatch for the battery, and I put the battery in there, tape it in place, and then plug it in as I put the hatch on. That way, it leaves all this room here for experimentation in the future, because I can always cut more or glue stuff back in here. And I did the same thing here. I cleared this area out just to give room for this and that. And the real reason for this postscript, a lot of you guys are just going to throw power at it. And I tried that. I tried that already, and that doesn't work. trust me, I know what happens. You see all this area here? That's a lot of area. And this thing weighs nothing. And you saw in the video how with this little tiny motor, I mean, it's smaller than my pinky finger motor. And it actually ran pretty good because it's so light. It doesn't weigh anything, especially using the smaller batteries that I was putting in here. I think I was using a 500 milliamp battery, little tiny thing. There's an awful lot of lifting area here, and it lifts real good on the water. Given enough power, it lifts real good in the air too. So you're going to have to find that balance. And that's the real challenge. You want enough power that you can blow it off the water in the worst of conditions, but you want it to be fast enough too. So, or you can keep it on the water in tough conditions without blowing it off. I mean, if every time you hit the trigger, it blew off the water, it wouldn't be fun. If it blew off the water once in a while, yeah, that could be kind of cool. So that's kind of what the power I'm looking for. That you could blow it off the water if you really tried, you know, running upwind. I mean, that's why the full-size hydro guys in the 50s started going to the pickle forks. They were just reducing all this area they had by, you know, moving the bow back until, you know, now there's just a little wing holding up the sponsons. So be careful in your power selections. Think hard. And one of the cool things is you can build 3 or 4 of these at a time for about the same cost as building one. I mean, you buy a couple blocks of foam. I mean, and in the process, I'm going to take you through the process here in the next few videos. I've got this box of foam parts, and we're going to be using the light table here as a flat surface to glue everything on, because we're going to use that expanding glue, and I'll show you that it wants to push the parts or the pieces apart, and we're all going to make it work. So there you go, a little postscript to my previous vid. Let's get the box of foam parts out of the way so the stink bug works, looks acceptable, and jet out.